Good. Okay, so big data is a big topic. We've already looked at, well, there was a question just now on privacy. That's interesting because I'm going to talk about privacy, but not in the way that we've typically thought about it. Ayana gave a presentation at the outset on the value of data, and she said the data is actually like ideas. It's sort of cheap. It's what we do with it. I don't agree with that either. I think we should have a healthy debate about it. It's not that I disagree. It's just that I think that there's lots of different ways to look at this issue. Let me think about big data and crystallize it to remind us how we got here and where we are and what we're doing by telling you a story and telling you the story of one of the foundational sort of papers in the area of big data. Now, we've had statistics for several hundred years. We've had analytics. We've had machine learning that started from the 50s, but it didn't really work. It works now. But big data, as it was coined in its modern instantiation, does have sort of a founding moment. And one of the key papers comes back from the most humblest of sources, and it's at Microsoft. Who would have thought? Okay, so around the year 2000, several researchers at Microsoft Research were asked to improve the grammar system of Microsoft Word. Sounds very basic. So you type into something into Microsoft on the Word processing program, and if you get a misspelling, like an R, date R instead of data, well, it gets a little red squiggly line because it says, hey, it's misspelled. But something else, of course, is there's a green line. And if you have the grammar that's wrong, you get a green squiggly line. We sort of all know this, right? And so here it is. The world of big data has changed since the term was coined. You wouldn't really say changing, since it just makes no sense, right? So there's now green squiggly underlined. And so how would you possibly know how to improve it? So you would use the data, and how they did it is with an algorithm. It's a machine learning algorithm. And they needed to know, well, how do we improve it? Because it's not as good as it needs to be. What do we need to do? So do we improve the algorithm? Do we take known algorithms and just change different parameters and different features in what we want to study? And so as the researchers were looking at it, they realized something. Every time they use as a training set their data, they use 500,000 words, and that's a lot of words, but it turns out that there's actually quite a few more corpuses of data, corpora of data, that they could be availing themselves of, and so they decide they're going to do that. And so they realize, hey, we're using 500,000. What happens if we use 1 million words? There was an improvement. Well, that's interesting. They ran it across 4 different algorithms. They all improved. Okay, that's great. And they said, well, they got very excited. They say, what if we actually use more data? Let's throw more data at the problem. So they increase it by an order of magnitude. Now they're using 10 million words with which, as their training set, to teach the algorithm how to understand if there's a grammatical mistake or not, based on what it should look if you were looking at these word sequences and types of speech. They get more excited still. They realize there's greater corpora of data in the world. They go to another order of magnitude to 100 million until they get to 1 billion words. Okay? And when you have 1 billion words of training data, suddenly your grammar works much, much better. You did not improve the algorithm. You didn't even tweak how you did it. It didn't matter that you had faster processors. It didn't matter that memory was less expensive. All those things were sort of nice to happen and operating in the background. You simply added more data to your model, and you suddenly got a huge improvement. And weirdly, you can see that the best performing algorithm with a little bit of data, with 500,000 words, it improved. It was fairly good, right? It's memory-based, right? It just looked at the front and back of the words prior to the ones that they're trying to study. But the least performing algorithm with small amounts of data actually became the best performing algorithm when you had big data. And so we're now in the big data universe. You add more data, you do great things. Okay? And so they didn't have the term big data at the time. They just called it very, very corpora, very, very large corpora, rather. And at roughly the same time, Google was doing the same sort of techniques, applying it to lots of different things. And they came up with a paper several years later, The Unreasonable Effectiveness of Data. That's talking about translation. Okay? They went from looking at 1 million words to 1 trillion words. This was actually trying to understand translation. Okay, so we're in the big data era. What does it mean? Well, it's completely, bastardized in the press. Today it's just extremely general, and it simply means we're applying statistics and the scientific method to areas of life that didn't have a quantitative bent before. That's fine. We don't have to be religious about what we mean by big data, but we know that there's a very interesting phenomenon going on. It's fundamentally the idea is that you can do something when you have a large body of data that you inherently cannot do when you're only working with smaller amounts of it. Okay, that more isn't just more. That more is different. Now, I was told that we're not allowed to have any slides about the size of data, so I will not show you this next slide, which is about the size of data. But it is simply to say that if I were to show you this slide, that it shows that the amount of data in the world has grown by several orders of magnitude. Roughly there it's represented as 4 orders of magnitude since basically the 80s. The amount of processing power has also increased at roughly the same pace, interestingly enough, about 4 or 5 orders of magnitude from the 80s to today, and that's Moore's law. And so what that actually means is, if you want to understand why big data works, what's changed today than in the past is that we have 2 elements, 2 sides of the equation. One is that we have the big data engine, we have the big data fuel, and the engine is the faster processors. Better processors can do more, and the fuel is the data, right? Just like in the grammar for Microsoft, you add more data, you can improve the accuracy of what you're trying to do. You can indeed create entirely new things, right? Like Jim was showing, you can actually identify power consumption at a very granular level, so you can optimize how you run your energy grid. Okay. The idea is that when you do this, you can do things that you simply couldn't do before. You never could do before. We never even had the imagination to try to do before because, well, we couldn't do it, so we didn't even see it. But now that we have more data, we can do things that we couldn't do. The data in that respect has become an asset, right? There's a value to it. Now, Ayanna had mentioned at the very outset that the data was sort of plentiful and cheap, and I accept the fact that data is extremely abundant, but certain data is incredibly valuable. Right? In the last few months alone, IBM has spent billions of dollars, not on technology, but acquiring companies that actually hold on to data. Okay? They acquired 2 companies in the electronic medical record space, and they even acquired the Weather Channel. It's because this is a company that says, hey, we have all the technology, but the problem is we're dumb as a doornail unless we have data that we can learn from. Right? They need the data with which to turn it into a product and into a service. Okay, so, and of course, Climate Corporation, which was an insurer for crops in the United States for farmers, was acquired by Monsanto for $1 billion. This is about 3 years ago. And Monsanto did not buy Climate Corporation because they wanted to get into the insurance business. They acquired Climate Corporation because Climate Corporation had the data at the farm level of what yields were, and that would help Monsanto sell seeds. The data was incredibly important because you could actually interact on a different level with the farmer by saying, hey, I know what's going on, not just in your farm, but every part of the farm. You want to add more fertilizer here, less fertilizer there. You want to drill deeper here. You don't need to drill so deep there. You can drill higher up, and you can improve your yields. So the data was extremely valuable to them. Now, if we think of data as an asset, there's a parallel to the way we can think about it. It's like the banking sector. We can take our money and we can stuff it under our mattress, and we still have our money, and that's fine. But the beauty of the financial sector, and the banking system in particular, is you take the money, you put it into a bank, and then the money recirculates. We call it the multiplier effect, right? And typically a single dollar bill or a single pound note will circulate between 7 and 14 times around the economy, being lent out into new people. Those loans get put into banks again, they get lent out again. And that multiplier effect increases the money supply, which is to say that by putting the money into play, into action, through a system, you get this greater value than the money itself simply has as a store of value when it's stuffed under the mattress. Now this, I would argue, has huge ethical implications for the value of data, but not in the way that we typically think about it. The question that was even asked by someone well-meaning, I think it's a legitimate question to have, is privacy. Right? Well, this is personal information. I'm not sure I feel very comfortable with it being used. But then again, if we can see that this person's or everyone's energy bill might decrease, that our energy consumption might be better because we learn more about it, and indeed that we can thwart the effects of climate change, which is a systematic way of the way that we steward the resources of the planet, we'd say, well, hey, this is pretty good. Like, yeah, there's a privacy interest. Let's be mindful of that and protect against that. But we have to use this data to get the value from it from a socially beneficial way. So the good news is that we can use this data in new ways that we couldn't do before to do things that we couldn't do before. And that's great. The problem, though, is that the data isn't as accessible as it needs to be for us to get this great value from it. Let me tell you a second story. And the second story is about a very, very nasty bacteria called Clostridium difficile. So C. difficile is known more commonly as hospital infections. Right? Millions of people get hospital infections every year. In fact, I think as we all know, if God forbid we have to go to the hospital for either routine surgery or an emergency situation, the most important thing we could do to improve our outcome as a patient is to get the hell out of the hospital as soon as possible. Right? Because the longer you're in the hospital, the more likely you're going to get an infection. And the infection, it kills, as a complication, it kills hundreds of thousands of people a year in the West. But even without the complications, just the actual bacteria itself kills tens of thousands every year. And hospitals spend billions of dollars trying to prevent it. And that's good. And we have models to do that. Right? We've got a substantial data set with which to understand who's likely to get it and how we can intervene on it. And we use 11 different variables. And that's very typical, the way that we've thought about it in a traditional mindset, right? Well, when you take an issue like this and you take it away from the medical practitioners and you give it to the computer scientists, you get a very different outcome. When you use a machine learning algorithm, you don't look at 11 different variables. You tap all the data you have, and a paper by some researchers at MIT used 10,000 different variables. Using the 10,000 different variables, they were able to increase the accuracy of the likelihood who was going to get C. difficile or not, in the same way that the Microsoft researchers were able to increase the accuracy of how to understand grammar, right, and to make it better. This is great. This is a great win for everyone. The problem, though, is that to understand all of these variables, although you can anonymize the name of the patient, all of the information that goes into the model can absolutely identify who the person was. You know age, you know gender, you know complication, you know when they were in the hospital, you know every single person, the name of the doctors and the nurses who treated that person, the room that they were in, right? Everything around the patient experience is recorded, blood type, DNA if it was taken in, and suddenly what seems to not be personally identifiable information is. The problem is that privacy law actively obstructs this very valuable technology from being put into play. Now, privacy law is great, and we need privacy laws, but the difference is that we need smart privacy laws. We need modern privacy laws that recognize the current state of the technology so the two things can operate harmoniously rather than in conflict with each other. Now, traditional privacy law actually has a modern birth. The earliest form was in the early 1900s, related strangely to photography. That was the difficult thing that we thought we needed to protect in terms of privacy. It was the great technology of the era. Modern privacy law in the computer age dates itself from 1980, and it's something called the OECD, the Organization for Economic Cooperation and Development. Now, it doesn't matter if you're an OECD country like Britain or America. Essentially, every single country's privacy law is based on these principles, and the three most important principles is called the collection limitation principle, the purpose specification principle, and the use limitation. So collection basically says, collect as little as possible. Paragraph 9 says, you have to identify at the outset what you plan to do with the data. And the third one says, once you've fulfilled the purpose of the data, get rid of the data. The problem, if you apply these rules, you have people dying of C. difficile in the hospitals because you can't use this technology with these set of rules. And although no one overtly made a decision in 1980 that we were going to allow people to suffer and some people to die just to protect their privacy, they lose their life, but they have their privacy, the fact is that is the implication, that is the effect of how the rule is put into place. So I think we need to probably change these rules. we can sympathize with the way that the thinkers brought up these principles, because this is what computing looked like in 1980. Sharing data was really a sort of like a contractual arrangement, right? A mainframe arrangement. This is how computing looks like today. So the reason why all of this matters is in part because we can actually improve things in terms of healthcare, but there's bigger stakes involved as well. If we change the default setting from that which is prohibited to that which is permitted, we get some of these great gains that we'd otherwise miss. We can think about the world in an entirely new way and try to identify ways in which we can use data to harness its value. And the reason why this matters is not just because of ordinary healthcare situations, it's because of the tragedy of what happened in Ebola, which was raging just a year ago today. We're calmer about it now because it seems like we staunched it, but that was just luck. Now, when the Ebola crisis emerged, many epidemiologists were very excited because they said, hey, we can actually apply data in new ways to help prevent the outbreak of it. And indeed, using call data records, looking at where a phone is and where it's traveling to over time, it's a very effective model to get a sense. It's just a model, it's just a proxy of the spread of disease. If you see from an area of high concentration of Ebola, a lot of mobile phones traveling somewhere else, you know how long they're taking, you know the transport route that they're taking, the network hubs that they're stopping at, and so you know where to intervene to staunch it, and you can get this data at real time. Things that in other outbreaks, just SARS a decade ago, you didn't have this information, and now we do, and that's great. And there's a lot of research around how to do this, right? We've applied it to malaria, for example, with very good effect. But the problem is that that data, these call detail records, were not made available, again, by the carriers who were citing privacy. So now we're in a strange situation in which the telecom carriers is trying to preserve the privacy of subscribers, many of whom will lose their life because their anonymous records were not being shared. So this is a bit of a problem, right? And what will it take to change this set of situations in which we have a sort of an Alice in Wonderland world in which we want privacy above the value of life? It's going to be a change in our values, and that's why there's an ethical implication to big data. Now, I'd also argue that for all of you in your jobs, you have the same issue, because you're going to come against privacy law, and I think if we just have a knee-jerk respect for it, that's wrong. In our lives, and particularly in our democracies, we don't have a knee-jerk respect for authority at all. The whole point of governance is to challenge our leaders and try to understand what's best and answer questions for us today. Big data is an infrastructure, and these infrastructures, if they have ethical implications, there's a matter of human rights, and it requires leadership at the level of the code and the workbench, as well as the boss, to say, well, what are we going to do and what's the best way forward? I think if we do that, we see that we're interconnected in ways that we couldn't imagine. The data is not just some sort of abstraction, but it's about human beings and people. And if we use the data wisely, we'll have a better world. Thank you very much. There are two questions, I'm told. Oh, I see one. There's one there. Please.
Not entirely related to your talk, but talking about how privacy laws need to change with big data, is there any movement towards laws changing about the interpretation of data? Just this week, every single day of this week, one of our major newspapers has committed a travesty against the interpretation of data. The Sun this Monday with their 1 in 5 Muslims. The Times yesterday commissioned a poll which suddenly came out with the results that they expected it to and published them. And today's Daily Mirror, which atrociously says that 770 babies die a year based on a slightly dodgy BMJ paper which they completely misinterpreted. When will we have laws equivalent to libel or slander for the misinterpretation of data?
So that is a great question. So the question is basically repeating it for the remote people. When will we have laws governing data just as we do for libel and slander because of the misuse of statistics in the press and elsewhere? I think it's a super question. I've never even thought about it that way, but I sort of want to subscribe to it. You want a sort of like good housekeeping seal of approval applied to, say, polls that the media does, or in the case of academic papers, even papers. You could even imagine a role for the RSS, the Royal Statistical Society, to actually have experts on hand to actually look at the methodology and either approve it or not. And things that are unapproved should be like a warning label, use at your own risk, and things that are proved you have more confidence in. So the answer is it's not going to happen. Free speech allows speech that is completely daft. We even saw, as you know, the tragedy, there's about 15 years ago in Britain, there was the woman who sadly had a child who died of cot death, and then there was then a second child died of cot death as well. A statistician was brought in as an expert witness for the prosecution who said the likelihood of these two children dying was basically 1 in 37 million, because he basically took the likelihood of one child and multiplied by the likelihood of another, because these seem to be two separate and independent incidences, like flipping a coin, which of course any person with a rational thought might say, well, maybe there was a genetic predisposition or there's something else in the house that made it more likely these were not independent. And of course, the misuse of statistics was actually convicted her, and she had to get out on appeal when smarter statisticians, other than the fancy professor, was able to say, no, this person was completely wrong. Oh, thank you. It was a doctor, not a session. So yeah, very relevant. That's exactly right. So yeah, I mean, I totally want, my heart is with that. I subscribe to it. Not going to happen, but let's try to move in that direction. Yeah.
Let's get one quick one.
Yeah.
Yeah, you mentioned about more data, better predictions. I just wonder whether it's actually variety that gives you better predictions. And the problem with adding more and more similar data in doesn't enrich it as much as actually looking for a variety of data, and that'll actually give you the robustness.
Great. It's both, and it depends on the use case. So it's a really good question. In the case of the grammars, it was not variety, it was just simply more data to increase the knowledge of what was going on. But in the case of because it was the same, if you will, data set, it was just more of the data to get a longer set of decimals on the probability of incorrect or correct. In the case of the C. difficile and the medical, it was absolutely the variety of data. Things that were strong signals that you wouldn't have thought to look for surprised the researchers. Zip code was or postal code was a very big predictor of the likelihood. Something that wouldn't be in the billing record, but would be in the medical record, because the patient record, because the person checked into the system. So it was in that case, it was absolutely variety. Good. Thank you very much. Sure.